Let's take a look at this example. The very first thing which we're supposed to realize that this is a series parallel circuit. Okay, so we have the components which are in series, and we have also two branches which are parallel. Okay, because I have already points A, B, in order to avoid the confusion, I'm going to call these 2 points X and Y. Okay, so the very first thing which I'm going to do, I'm going to simply find, I'm going to label the currents, I suppose to say. Okay, so I'm going to call this current, which will go through these components, I source. Okay, is given. I source is equal to 35 milliamps. Okay, so this is my I source. Other words, also I can say this is my I total, and this is going to be my current I1, and this is going to be my current I2. Okay, so the current I1 will go through these two components, I mean R3 and D3, and I2 will go through these 5 components. Okay, these 3 diodes and these 2 resistors. So we have to remember that I source is equal I1 plus I2. Okay, this is the KCL, and this is my total current. Total current is going to split into 2 currents, so if you are going to add these 2 currents, you are going to end up with I source. Okay, so first what I'm going to do, I'm going to write the formula for I1 and I2. So let's take a look what we can do over here. So I have I1 is equal Vxy minus the voltage drop across the diode D3, VD3, over the resistance R3. So this is equal Vxy minus VD3, this is silicon diode, so this is minus 0.7 volts, over R3, which is equal 5.2 kiloohms. Okay, so this is equal, I'm going to simply rewrite this fraction as 2 fractions. Okay, so I have Vxy times 1 over 5.2 kiloohms minus 0.7 volts over 5.2 kiloohms. So this is my I1. I1 is equal 1 divided by 5.2 exponent 3. This is equal 192.3 microsiemens. So I have Vxy times 192.3 microsiemens minus 0.7 divided by 5.2 exponent 3. This is equal 134.61 microamps. Okay, 134.61 microamps. Okay, so this is my I1. Next, I'm supposed to find I2. I2 is equal Vxy voltage between these 2 points minus the voltage drops across the diodes divided by the total resistance of these 2 resistors. Okay, one more time, Vxy minus voltage drops across these 3 diodes, because I'm looking for I2, so that's why I'm looking at this branch, divided by the total resistance of these 2 resistors. So I have Vxy minus VD4 minus VD5 minus VD6 over R4 plus R5. Okay, so this is equal VXY minus VD4. This is germanium diode, so this is simply 0.3 volts, minus VD5 minus 0.7 volts, minus VD6, which is equal 0.3 volts, over R4, which is equal 3.3 kilo ohms plus 1 kilo ohm. Okay, so this is equal, I2 is equal VXY minus negative 0.3 minus 0.7 is minus 1 volt, minus 0.3 is minus 1.3 volts, over, okay, this is 1 kilo ohm, 4.3 kilo ohms. Okay, so I can rewrite this as VXY, okay, 1 divided by 4.3 kilo ohms minus 1.3 volts divided by 4.3 kilo ohms. This is equal, I2 is equal 1 divided by 4.3 exponent 3. Okay, so this is equal 232.55 microsiemens. So this is my VXY times 232.55 microsiemens, and I have 1.3 volts, 1.3 divided by 4.3 exponent 3. This is equal 302.32 microamps. So minus 302.32 microamps. Now we're supposed to get back to the formula, which says that I source is equal to I1 plus I2. I source is given, is equal to 35 milliamps. So I'm going to write this down. 35 milliamps is equal I1, and this is my I1. So I have VXY times 192.3 microsiemens minus 134.61 microamps plus I2, and this is my I2. Okay, so I have VXY times 232.55 microsiemens minus 302.32 microamps. Okay, so next I'm supposed to bring all currents to the left side and VXY leave on the right side. So I have 35 milliamps plus 134.61 microamps plus 302.32 microamps. This is equal VXY 192.3 microsiemens plus VXY 232.55 microsiemens. Okay, so now I'm supposed to add these values. So I have 35 exponent 3 negative plus 134.61 exponent 6 negative plus 302.32 exponent 6 negative. This is equal 35.43 milliamps. Okay, and this is equal Vxy. I have 192.3 exponent 6 negative plus 232.55 exponent 6 negative. This is equal 424.85 micro Siemens. Now, in order to find Vxy, I have to divide both sides equation by 424.85 microsiemens. 424.85 microsiemens. So I'm going to have Vxy is equal, so I have 35.43 exponent 3 negative divided by 424.85 exponent 6 negative divided by 83.39 volts. 83.39 volts. So this is my voltage Vxy. This is the voltage between these 2 points, okay, Vxy. But the problem is not asking me for Vxy. The problem is asking me to find voltage source and VAB. In order to find VAB, I'm going to find current I2. Why I2? Because I2 will go by the resistor R5, okay, and keep in mind that the sum of these voltage drops will give me VAB. That's why I have to find I2. Okay, so let's continue. So this is the formula for current I2. Okay, I2 is equal Vxy minus 1.3 volts over 4.3 kilohms. Okay, so it came from these calculations. Okay, so let me copy this down. I have I2 is equal Vxy minus 1.3 volts over 4.3 kilohms. So this is equal Vxy. We found this is 83.39 volts minus 1.3 volts over 4.3 kilohms. This is equal 83.39 minus 1.3 equals divided by 4.3 exponent 3 equals 19.09 milliamps. This is my I2. So now if I want to find the voltage VAB, VAB is simply the sum of the voltage drops across these two components. I can say that VAB is equal VD5 plus I2 times R5. Okay, so this is the voltage drop across this diode plus voltage drop across this resistor. So I have VD5 is equal 0.7 volts plus I2, which is equal 19.09 milliamps times R5, 1 kilo. This is equal we have 0.7 plus 19.09 exponent 3 negative times 1 exponent 3. This is equal 19.79 volts. Okay, so this is my VAB. Next, we are going to find voltage source. Okay, and we are going to use KVL to do that. Simply, we are going to add the voltage drops in this loop. Okay, so we are going to add VR1, VD1, VR2, VD2, VXY, VR6 and VD7. Okay, so let me write the formula for it. So I have voltage source is equal, because I have resistor R1 and I have I source already, so I have I source times R1, this is my voltage drop across resistor R1, plus VD1 plus I source times R2 plus VD2 plus VXY plus I source times R6 plus VD7. Okay, so this is voltage source is equal. I can factorize I source from these three terms and simply write I source times R1 plus R2 plus R6 plus VD1 plus VD2, okay, plus VD7 plus VXY. So plug in the numbers. Voltage source is equal I source 35 milliamps plus R1, which is equal 1 kilo, plus R2, which is equal 2 kilo, plus R6, which is equal 1 kilo, plus VD1 0.7 volts plus VD2 0.7 volts plus VD7, which is equal 0.3 volts, plus VXY, which is equal 83.39 volts. So I have voltage source is equal. Now I'm going to use the calculator. So I have 35 exponent 3 negative times the parenthesis. I have 4 kilo inside of it. 4 exponent 3 plus we have 1.7 volts plus 83.39 volts. This is equal 225.09 volts. So this is 225.09 volts. So we found VAB and we found voltage source, so we can say that the problem is solved.